Hello, my name is Braden, and today I'm going to be talking about the understanding of the value of powers with whole exponents. So, Unit 3.1. Um, First off, let's talk about what is a power. So, a power is a base with an exponent. For example, we got a random number like number 4. That would be the base, and this right here in the corner, number 2, would be the exponent. So what this means is, if the exponent is 2, you would be multiplying the number itself twice. So therefore, if you do 4 times 4, that would be 16. And if you combine the exponent and the base together, that would equal as a power. That's pretty much simple. So if you were to change the exponent, like say put it to 4 3, it would be 4 times 4 times 4, and that would be 64. That's if you'd only change like the exponent. That's pretty much it. That's the basic things of what powers look like. Let's do it with negatives now. So for example, if we had a bracket with a negative in it, and let's say 5 squared. So if there's two different types of ways, if the negative is outside the bracket and inside the bracket. So if the negative is inside the bracket and the exponent is even, it's going to equal as a positive number. But if the exponent is going to be 3, then it's going to be a negative number. So if it's an odd number, it's going to end up as a negative number. But if it's a positive, it will end up, if the exponent is an even number, it will end up as a positive, if you know what I mean. So say negative 5 squared, that would be 5 times negative 5, that would be 25. But then if you would do negative 5 3, and the exponent is 3, negative 5 3, that would be like this. No. Equals negative 25. You know what I mean. And then if the negative is outside the bracket, so say we'll go right here, negative 6. If it's gonna be like that, then the outcome of it would always be a negative number. So 6 squared, that would be 36, negative 36, and so on. Yeah. So let's try to problem solve now. Oh yeah, wait. Let me just explain what the repeated multiplication is and exponential form. So exponential form is pretty easy. If you have repeated multiplication, like 3 times 3 times 3, the exponential form would be 3 3, because the base is 3 and there's 3 of them, so the exponent would be 3. If it's gonna be if you have an exponential form like 7 squared, the repeated multiplication would be 7 times 7, because there's two sevens, so you have to multiply them. That'd be 49, obviously. Oh yeah, and for this, it would be 27, because 3 times 3 is 9, times 3 is 27. Pretty simple. Now let's do a problem solving equation. So I'm gonna find one from the textbook real quick. Oh yeah, here. Found one. Number 13. So under ideal conditions, a signal bacterium doubles in number every 30 minutes. Create a table to show the situation. So we'd have to create a table. So it says right here that every 30 minutes a bacterium doubles. So what we would do here is, since it starts off as 2 3 minutes, because a single bacterium doubles. So 3, oh no, 4, I mean, that'd be 60 minutes. So hours, number of bacteria. My bad if I don't have any space. So it would double, so it would be 8, and then 90 minutes, and 16, 120 minutes, and 32, 150 minutes, then 64 bacteria, 3 hours, or 170 minutes. You can put it whatever you want to put it, so like 1 hour, 2 hours, oh not 1 hour, half an hour, 1 hour, 1 hour and a half, yeah, so on. So that's pretty much it with the table. The next thing we would have to do is letter B and see if this is a linear relationship. So since it's continuing on and it keeps doubling itself up, it's going to be a linear relationship, just because if you put it on a graph, it's gonna be a straight line, because all these numbers are factors of each other, so it would be able to fit in properly. So it is a linear relationship. Letter C. What we have to do here? Use powers and exponents to create a formula that describes the relationship between time passed and the number of bacteria. So since the time doubles every 30 minutes and bacteria doubles each time, so like if there was 2 bacteria, there would be 4. If there was 4 bacteria, it'd be double to 8, and then double to 16. So what I put, I might be wrong, but it's just my logic. I did 2 squared equals 30, because 30 is the time passed, and it goes for every half an hour, and 2 squared represents how much bacteria goes every 30 minutes. So 2 squared is 4, and then it keeps going on and on. Yeah, that's what I wrote. How many bacteria would be passed after 5 hours. So after 5 hours, 3 hours 30, 4 hours, 4 hours 30, 5 hours. So you have to double this again, so 64, that'd be doubled it to 128, then 128 times 2 is 256, then 512, 1024. I already wrote this on my paper because I already did this before, so I didn't want to think too much, but yeah, you get my point. So the answer here, in 5 hours, there would be 1,024 bacteria. Oh, sorry if my phone isn't straight, but yeah, you see there. So that's pretty much it for understanding the value of powers with the whole exponents. To summarize this whole thing up, all you need to understand is the base and the exponent. Base is the number you'll be multiplying itself by, and the exponent is how many times you're gonna be doing it. And same with the negative. If there's a negative in the bracket and the exponent is odd, it's gonna be a negative. But if the exponent is even, it's gonna be a positive number in the end. So yeah, hope you enjoy.